welcome back. Here is another reflection, except this time it's about the line y equals x. And this is a little tricky one. Maybe you already know it. If you do, skip to the end to check the answer. But I'm going to try and explain this one. A lot of your math teachers say, like, oh, there's a hidden number in front of this y. And that hidden number would be a hidden 1. Like there's one y there. And the same thing applies for our x. There's a hidden coefficient of 1. And starting from the origin, you can kind of plot out this line by following these directions. In the y direction, you're going to go plus 1. You're going to go up 1. And then in the x direction, you're going to follow that direction, plus 1. You're going to go to the right 1. And if you plot that point will be on the line. Sorry about that. That point will be on the line y equals x. So I'm just going to follow those directions, all right? I'm just going to keep on going up 1, over 1, and then plot a point. Up 1, over 1, plot a point. Up 1, over 1, plot a point. All right? And it works in the other direction too. This is this, positive times a positive is positive, and a negative times a negative is still positive. So, I could likewise go negative y, and that's the same as negative x, right? So instead of going up and to the right, I can go down and to the left, right? And when you do this, you fill in your line y equals x, and just throw it in there, and it looks like that. Maybe you already know that one from your algebra class, all right? But here's a way to remember it if you needed it. So this one's a little bit tougher to reflect over this line. It's not, perfectly vertical, and it's not perfectly horizontal. So, counting boxes on the grid, it doesn't make a 90-degree angle. It makes like an acute angle. And if I go this way, it's the same thing. You're making this acute angle. So when you have these slanted lines, throw this back in. When you have these slanted lines, you need to change up your method. You still need to make that 90-degree angle, but the way we're going to do it is we're going to cut across the boxes. We're going to count diagonals, because there's our 90 degrees. So if G is diagonal 1, its image will be the same amount diagonally, 1. So it will be G prime. And F is 1, 2 and a half, 2.5. Its image will be the same amount. It will be the other half of the box, and then 1.5, 2.5. It will be out here, F prime. And H, we do the same thing. 1, 2 and a half. Here's the other half, 1.5, 2.5 to finish it. So right there, H prime. I'll clean up my lines, my work, and then I'll connect my graph. And I got a little lost there because I got confused by these points, and then I quickly looked at the letters to kind of reorient myself. So that's why it pays to be precise when you do math. You don't get lost in these times. So F, H, and G. And there is our reflection. Across the line, y equals x. Across that line, y equals x. See you in the next problem.